Good evening, sir. Lord, I was
Wait
just
for,
sending Coco the link.
wait for 2 more minutes and then we'll
He's
start.
already joined. He joined before you.
Hey, Nitish, I was just sending Conguel the link. How is that wrong? Ask Conguel if you want.
Did he send you the link?
Hey, you can't blame Sankar, bruh. Such a great man.
What?
They just tell if I sent the link or not.
He didn't send me the link. What link?
They.
What link, bruh?
Oh, I'm gonna share my screen.
What link? I don't think you can.
I'm joking, I sent it.
Oh wait, you can. Okay.
Okay, look at this. You can see, right?
No, you didn't share your screen.
I did.
They actually shared us. Stop it, bruh. We can't see anything.
In the comment 2 more. In the comment next 2 seconds.
Okay,
This,
can you
don't
see
share
now?
your screen. Don't
Sir,
share your
look at this,
screen.
guys.
Stop
Yes.
this.
He wants to see.
So that's what we both were saying, sir. We both trusted him, sir, but he didn't believe that we trusted him.
Oh, sir, these guys are. Don't believe them, sir. You know you should not believe them.
Sir, you.
Oh my God.
Sir, you taught us that cross multiplication when we were like our maths. When you were taking maths for us, sir.
So you remember teaching us cross multiplication
You
in
weren't there,
maths,
okay?
right, sir? When I wasn't there, but I did learn. That doesn't
So
mean that
he say that
he didn't teach me.
we
Excuse me, sir. Sir, are you there? Sir, you're muted, sir.
Yeah, we'll wait for 2 minutes and like for Tarun and then we'll start.
Yes.
Please message him.
Sir. Yes, sir. Sir, you remember you teaching us cross multiplication, right, sir? The in maths.
linear
Cross multiplication.
simultaneous.
Yes, sir. Yeah, when Sapan sir was absent, like he didn't teach that. He said you're gonna teach the chapter, and after few days she'll come again. You remember, sir? You taught us, oh, sir. Guys, can you hear me? Hello, am I audible?
माइंड ही चेंज कर दी, मेरा माइंड ही डिस्टर्ब कर दी. हम पता हम कुछ नहीं पढ़े उतना देर से. हम कुछ नहीं पढ़े उतना देर से. हम एक बार आके फिर से सोचे इस चीज को. The
Ponguel,
term
you
you
finish
said
your
was
artwork,
just
Ada?
unbelievable. You said that there's something apart from love, and that is my
Hey,
shop.
Ponguel, we can't hear. Okay, he left.
I love you because you can make money. तुम पहले ये बोले थे कि वो अलग, वो बात का बात था.
Moda, we
पहले ये
can't
बोले
hear
थे कि
you.
तुम प्यार को और मनी को साथ में लेके
How will
चलते.
you hear me if I didn't speak, bruh?
So I will just ask.
Hey.
हम पूछे थे कि नहीं होगा
And then
तो तुम बोले
I
तू
was
कुछ नहीं
smart and
बोला.
asked, "Are you speaking?" This is why I took the champion's badge from him.
हम पूछे हम बार बार तुम्हारे साथ रहेंगे, हम बार बार ऐसे झगड़ेंगे तो तुम बोले कि तुम
Very nice.
फिर अनश्योर हो. शायद हम ऐसा नहीं बोलते बाबू.
Tarun's not joining, sir.
Oh.
हम नहीं, तुम उस समय ऐसा नहीं बोले. I'll talk to you at 6. I need to teach them. I'll call you exactly at 6. It's not about feeling low. It's about feeling I'm doing something for myself. Because earlier I used to do something for
Let's
you,
go, Tarun.
but you say like this. I won't make you my aim.
Yes,
Then
we can hear.
I'll talk to you at 6.
Okay, just check it.
No, no, we can't hear you because you're not speaking there. But we can hear you if you are speaking there. But we can't
Hello.
hear you even if you're
Am I
speaking.
audible?
Yes, sir.
Okay, let's start then. Tarun is here. Yeah, what were you asking, Sankalp?
So I was asking that in you remember you teaching us what is this science cross multiplication and simultaneous linear equation, right, sir?
Yeah, right. I did that.
Yes, sir. We are like
Hello.
so
Yeah, we can
our
hear you.
Hello.
ma'am
Hello.
told
Hello.
our teacher
Can hear
our
you.
teacher told
Pardon.
like a maths teacher. She told that it is the wrong method, sir. The one
Hey,
you
no,
taught.
sir is correct only. Sir is correct only. I just made a step wrong. Sir is also the same method only. I just made a step wrong. I checked
Are you
after I
sure?
came home.
Like, I did
Sir,
not teach anything wrong to you.
sir,
Or
you
something like
didn't
that.
teach cross multiplication. After I went, I checked what ma'am told me, and it's the same as what you taught us.
Okay, fine now.
You didn't teach us anything like B
Yeah, sir.
caps, sir.
Pardon?
Hey, no, I said beam that. Sir taught the same thing only.
Okay,
He
please
taught the
rectify it
same
because.
better. That's it.
Okay. Okay.
Hey, Tarun, we all can hear him. I think it's your phone.
Okay, so today we'll be starting a new chapter, right?
Let's go. Can you
That
hear
is. Yeah, you
me?
are
No, we
audible.
can't hear you there.
So, perception of liquid or pressure, or I forgot.
Pressure in fluids and atmospheric pressure. Pressure in fluids and atmospheric pressure. Okay, so this will be starting.
Yes, sir.
So this chapter starts with few terms, that is thrust and pressure. Okay, where's Tarun?
So, he went somewhere. Sir.
Where did he go?
I don't know, sir.
Probably went to
Somewhere?
take his book.
Or tell his mom that he can't hear.
Okay, Tarun's here back.
On-
Hastily. Okay. So this chapter starts with few words that I need to explain it to you. That is thrust and pressure. You know what is thrust? Is this chapter started in school?
No, sir.
Yes, sir. Sir,
So
we
we are
still
at-
It's
didn't
next
finish
class
first
will start.
chapter, sir.
Next
We
class.
are ahead of
We
them
even
now.
start first chapter, sir.
So we are ahead of them now.
Yes.
Yes, sir.
Yes,
Yes, sir.
sir.
One
Sir,
chapter
actually,
ahead.
we are actually way ahead of them, sir, because they didn't finish they didn't start the first chapter yet, sir.
Okay. So see here. So what is thrust and what is pressure? Okay. So thrust, it is the force. It is the force. Okay. Acting normally on a plane. It is the force acting normally on the plane. Okay. And pressure, it is the force
See, I wrote morning.
per unit area of surface. Force per unit area of surface. For example, see here. If let us we have a surface here like this, okay, and what I'm doing, I'm applying a force like this. Some force I'm applying, and that is perpendicular to the surface. That is at 90 degree, right?
That is the
So that force will be called a thrust, right? Now in the same case, what I have an area. I'm applying some force here, Okay, and that force is being applied on a particular area, that is A. So what is pressure? Pressure is force upon area. Understood?
So
You're applying the same
pressure
force
is
in how much area? In how much area you're applying the same force? That is called pressure.
so pressure
Okay.
is the thrust in unit area.
Yeah, we can say it like that. Pressure is thrust.
The area, the
Force
amount
by
of
unit
force
area.
Sir, A is
Pardon?
area, right, sir? Okay,
So
I
it
thought
is
that
the
was
amount of force
accelerated.
applied on an area. So I told correct. The amount of force applied on an area.
Yeah,
Not the
that's
amount of
correct.
force. I mean, it is the force that acting on the area. Amount of
See,
force
what is the
applied.
unit? So pressure is force upon area. What is the unit? For force it is Newton, for area it is meter square. So for pressure the unit is Newton per meter square. We can write it like this, or Newton per meter square. So as we had in force, we had mass times acceleration, and that was kg meter per second square. But instead of writing this big unit, we used to write what?
Right, Newton.
Newton. We used to write Newton, right everyone? So same
Yes,
here,
sir.
instead of
Yes, sir.
writing Newton per meter square, we'll be writing Pascal. The
Pascal.
scientist behind it. So this is said to be Pascal.
Thanks.
Okay. Now, what is 1 Pascal?
1 Pascal.
1
so
Newton
no one
acted
knows
on
this.
1 meter. 1 meter square.
Good. Who said that? Who said that?
Pascal, sir.
Me, sir.
Okay, that's really good. See, why I said that is good. He answered a very simple statement, but the thing is that whenever you are asked to define any unit, whenever, if you like don't know that, if I'm not explained that to you, and then also you got to know that in the exam that this particular unit is to be defined. So what you have to do, you have to go to the formula. Okay, go to the formula and then put every value as 1. Understood?
Oh, 1
So,
Newton force acting on 1 meter force. Oh,
exactly,
okay.
exactly. And that is how we have defined every formula, every unit. If you see the units at the past that we have defined, even how can you define 1 Newton, Nitish?
Kilogram meter per second square.
No, no, if I ask you to define 1 Newton, Tarun?
10 to the power of 5 dyne. Oh, Newton.
No, no, no,
Oh,
1
1
Newton.
kilogram. 1
So
kilogram.
1 Newton meter.
No,
No.
1 Newton.
See,
1 Newton.
so what you have to do, 1 Newton, if you have to define, what is the formula? Formula is force is equals to mass times acceleration.
Sir, amount
Oh.
of sir,
1 mass.
amount of force needed to move 1 kilogram of body 1 meter, sir.
Yeah, that you can say. Or you can say that if a body of 1 kg is being provided an acceleration of 1 meter per second square, then it is said to be acting on a force of 1 Newton. Like that you can say.
Yes, sir.
Understood?
That's what I said.
So
Yes,
whatever you have, whatever formula or units they need you to derive, like define. So what you do, you go to the formula, you put everything as 1, and that is how it is done. Even in class 11th and 12th, you'll be asked about the definition of units. Understood? So you remember this concept,
Yes.
then you'll never fail. Okay. So what is 1 Pascal? 1 Pascal?
So
Is
1 Newton of force acting on a meter. 1
Yeah.
meter square.
Is the pressure?
Sir,
Is the
but
pressure?
for second, not second. For meter and the length, you made a very hard definition, sir.
Which one?
One rod of aluminum, iridium alloy.
That you
Rod
don't have to
meter.
remember. See, that you don't have to remember. That was something defined like long ago, and these things have never been asked. We just need to know them, how it was done.
Sir, they
Okay,
asked it
those
in the
things
test
are different.
that you kept, the learning room exam.
Pardon?
They asked it in the learning room exam, sir, like the first.
Now, this time, see, these things are there. Now, they don't ask in the. I'm talking about competitive examinations. Okay, those in those times they don't ask this. Nowadays, like you are learning basic things. These topics are containing basic
Hey,
thing. The same
Nitish,
thing going low in class
Nitish,
11.
in exams, sir, in exams they give the most random things in life that we never use, sir. That's how exams are.
100 oranges.
Thing is that you don't solve questions. You don't solve
No,
questions.
sir,
That's
it's
why
like
you get something new.
sir, like as Nitish told, like they'll ask what 1 second
Hey,
is.
that was
Sorry,
great
one.
math. What are you
What?
talking about?
So didn't I make
Sir,
you
they
write?
lower-
Yes, sir, you did make
Yes,
it.
sir.
Why didn't you
Sir,
revise? Why didn't you revise?
I wrote it, sir.
I wrote,
Sir,
sir.
you
I wrote
gave.
it, sir.
Sir, in learning room test, they gave us how was 1 second discovered. It is actually the time interval of 9192683177 of vibrations of radiations corresponding to the hyperfine levels of ground state of cerium 133 atoms. I have no idea where to use this in life, sir. It's like very
So
random,
you have
sir.
no idea why you're even using it. That's not even your like grade.
Exactly. See,
You're
the
just
thing
using
is
your
that
mom's
now
economics.
these things are to be memorized. So that's why these questions have no place in big competitive examinations. See, when you're like getting an exam of a particular chapter, so you have to frame some questions, huh? And you can expect these things in a particular chapter wise examination. But you have mixed chapter examination, then these questions will not come. Okay, because we have most important other things from different chapters to be framed in the same 45 questions, but you have to frame 45 questions from only one chapter. You'll frame everything that you get, so that's why you got those questions.
Sir.
Okay, so write it down this page, everyone.
So finish,
One
sir.
sec, sir.
First is physics exams. I mean tests, sir. Yes, sir.
Hmm?
Sir.
First is physics test. It's on Friday.
I need every one of you to get good marks.
Yes, sir.
So I
Yes,
can
sir.
study full day tomorrow, sir. Tomorrow full day leave. Tomorrow we have leave.
Solve more questions.
Sir, actually, the laws of motion chapters numericals are actually easier than equation of motions chapters, sir.
If you'll solve, you'll find it easy. If you won't solve anything, you find it hard. This
Hey,
shows
this
that
take
you
a
haven't solved the questions of motion, laws of motion, and you have solved more questions of sorry, you have to not solve the questions of equations of motion, you have solved questions on laws of motion. Written, everyone? Shall we move on?
Yes, yes, sir.
Yes, sir.
Okay. So next thing, there are different units of pressure also. Okay, different units of pressure. Okay, what are they? So different units of pressure includes different units of force and different units of distances, right? So we can write it like kgf per meter square. We can write force instead of dyne per centimeter square. So this is called CGS unit. Okay, this is called CGS unit.
Oh, you mean it like that? Okay. Sir, it's like in each system, like CGS, FPS, all that type, different units. Is it like that?
Yeah, but everywhere we don't use that. See here, we won't be getting anything like FPS or MK system like that. Then we have bar and millibar. What is millibar? 10 to the power minus 3 bar, right?
Yes.
Yeah, 10 to the power. What's a bar?
We write 1 bar means 10 to the power 5 Newton per meter square or 10 to the power 5 Pascal. So if you're taking 10 to the power 5
Bar
Pascal,
is
then
the
you can
unit of pressure.
So what's a millibar? So what's a millibar?
I'm telling you, 1 millibar is 10 to the power minus 3 bar. Or you can say it as 10 to the power 2 Newton per meter square. Okay.
Yes.
Then we have torr. Torr means, before that you should write mm of hg. Mm of hg, this is a unit.
So it's
Okay.
there, right? Off
This
also.
is actually
It's used in barometers.
Yeah,
exactly.
it's used. Yeah,
Oh, millimeter of mercury.
millimeter of mercury.
I'll explain about it later when we'll see on it. Let me see. Do we have that? Do we have to calculate that?
So they won't ask us to convert from one unit to another unit.
Hmm. Okay.
They won't ask us
We'll talk about it. Yeah, they can ask it. They can ask it. So basically, what we have, then we have atmospheric pressure. Okay. You can say 1 atmospheric pressure is equals to 760 mm of Hg.
millibar is
80
10
ATM is
square now.
atmospheric, right?
Yeah, atmospheric. You can write it like atmospheric. You can expand it. Also, there is torr. So 1 atmospheric pressure is 760 torr. Okay. Or 1 torr is equals to 1 mm of Hg.
One atom equals 760. Oh, one atom
Also,
pressure.
It's
1 atmospheric
one
pressure, if
ATM.
you want
Yeah.
One
to
torr,
write in terms of
it's torr.
No,
Okay.
10 to the power
he
5
thought it was an atom.
Pascal. 760 mm of Hg is equals to 1.013 into 10 raised to the power 5 Pascal. These are the different units that you have to remember.
Sir, what is the one above R in the what is above R in torr, sir?
Here,
Yes, sir.
this
What
have
is it?
written or sorry, this have written or.
Okay.
Okay.
Oh, one torr is 1 millimeter of mercury. So one atomic.
Yeah.
Okay, nothing. Okay.
Sir, done, sir.
Okay, let everyone write it. This chapter is relatively easy.
Yes, sir.
So you
Sir,
have to
the
remember.
third chapter, sir.
No, this is the fourth chapter.
Fourth chapter it is.
No, I'm saying the third chapter was the easiest.
No.
That's good. That is one of the hardest chapter. If you find that easy, so you'll get more marks in the 11th
That
and
is one of the
11th.
hardest
Whatever you
chapters.
get the other semester. Pardon?
So the first chapter is
Sure.
very tough, sir. It's because it's very new to us, sir.
Yeah, that is there. Have you read it twice?
I've read it
Right,
more than
try to read
twice,
it.
sir.
No,
I
read
read
it once again and solve more questions. And if you have any doubt, we can arrange a doubt class. Okay, no problem.
Yes, sir.
Sir, you only
Everyone
teach
done?
for us. Sir, you
Pardon?
only teach for us. You only teach for us. You also teach other batches.
Some 11th and 12th batches I do.
Yes, sir.
Okay, done?
Yeah.
Shall we move on?
Yes,
Yes, sir.
yes, sir.
Okay,
Yes,
next
sir.
topic that we have is
Sir, you're currently in Delhi, right?
no.
Oh, no,
Jamshedpur.
yes,
Are you in?
I am at my home presently because I have vacations.
Sir, I mean like
Oh,
where are you? Like
States,
in
sir.
which state? Like in which country?
I'm
States,
in
not country.
no, I'm above your countries. I'm in Saturn.
No.
Sir, you can't be in
So you
Saturn,
must
sir.
have a
It's a gas ball.
so
Coming
you
to my
must have a
internet.
very no like so you must have a very good like network and a computer, so because you can still clearly see your video and
Okay, write it down.
In what
The area on
which
which
country?
thrust is applied. So it depends on the area on which thrust is applied.
Sir, can you hear me?
Like, yeah, I
Sir, when
did
you
not
said
hear that.
sir, when you said your state, my internet went off, sir. That Ava.
I'm in Jharkhand presently, Ranchi, the capital of it.
okay.
This is my
Sir, what did you write
hometown.
there?
See, factors affecting pressure. So pressure is directly proportional to the thrust and inversely proportional to the area. So basically, pressure depends on the area on which the thrust is applied, and second is the thrust. That is the force that you are applying. So on these two factors, it depends. So we either we have to increase or we have to decrease. So we'll be going. Huh?
The first point, sir.
The
The area, the area.
on which the thrust is applied. Area. Initially, when I used to take your classes, I was at my college.
Where is that, sir?
Yes, sir, you told. Jamshedpur in 80.
You remember this center, but you don't remember what center.
Who said I don't remember?
Why do you get?
Why do you get?
Written, everyone?
Yes, sir.
So,
Everybody, Tarun written?
Sir.
Shall I change the page?
2 times you're still writing out.
Okay.
yes, sir.
Now see here. We'll be seeing here, for example, I have to apply 10 Newton of force that I can apply maximum. Okay. And I have a brick like this. Okay. This is a brick. Right.
Yes,
So if I can tell you, let us say this dimension is 10 centimeter, this dimension is 20 centimeter, this dimension is 5 centimeter. This is phase 1, this is phase 2, and this is phase 3. Can you tell me which phase will give me maximum pressure and which phase will give me minimum pressure?
One.
I have to apply the
Sir,
10.
maximum.
Take classes one
Sir,
at a time.
maximum pressure is 3, sir.
One at a
Sir,
time.
maximum pressure.
Wait a minute.
Sir, the math.
Oh yeah, right. Oh yeah.
So Sankar, you tell me.
Sir, maximum pressure is 3 and minimum
Hey,
is
shut up,
1, sir.
Shut up. Ask Kongwil, sir. Sir, ask Kongwil first.
Kongwei, maximum pressure
Sir, 3, sir.
and minimum?
1.
Okay. Nitish?
The same, sir.
Same. And Tarun?
Same, sir. So because 3
If
is
you
at the
answer
bottom.
same, you have to explain that. Why is that?
Because 3 is at the
Because
bottom.
3 is like a
Please let him answer. Let him answer. I know you know.
Sir, because the 3 is at
3
the
is at the
bottom.
Bruh.
Trees?
The bottom.
Makes no sense.
Please, I cannot hear him. Please be quiet. Because 3 is Tarun, what did he say?
Because 3 is at the surface. Say.
So what?
So, yeah, I thought that was the answer. Never mind.
Bruh, then why
No.
is okay now
See.
it's not that one.
Tarun, see here. Tarun, see here. What is pressure? Pressure is force upon area, na?
Yes, sir.
How much force do I have? 10 Newton. So I'll be applying 10 Newton in all the 3 cases.
Yes, sir.
The pressure
So this is a
area
constant
is
for me.
proportional.
This is a
Yes,
constant
sir.
for me. That
Yes,
means
sir.
pressure is inversely proportional to area. If I increase the area, pressure will decrease.
Yes, sir.
Which surface has got maximum area? Tell me.
Sir?
Which surface of 1, 2, 3 has got maximum area?
Sir,
Object
3.
not to scale.
Hey, hey. Maximum
I'm not
area
hearing
three
you,
answer.
sir. I'm not
Maximum
hearing you,
area.
sir.
This one is the maximum area. This one.
It has the maximum area, sir. Sir, I'm
What
not
is the
able to
area?
hear
10
you.
into 20. 10 into 20. This is the area. Minimum
Yes,
area
sir.
is this one. Minimum area is this one.
Yeah.
The minimum area.
Minimum area is 3.
Understood? So less area means more pressure. That is why they said maximum pressure in area 3 and minimum pressure in area 1. Understood?
Yes,
Yeah. Now I leave it, sir.
Maximum area three.
Okay, now see here. We have some examples. Cutting tools have
Sharp
sharper
ends.
edges.
Sharp ends. To
So
decrease
because the
pressure,
area applying on it
area-
has is very
I already
because if
said
the area decreases, the pressure
Totally
applying
no
on
one
it
knew.
should also
Okay.
decrease.
Exactly. For the same pressure, if you decrease the area, for the same force, if you decrease the area, the pressure will be more, right?
Yes, sir.
Then if I write it like this, wide wooden sleepers
Okay.
are
So what?
So we are living in
Please.
Norway.
wait a minute, below the railway tracks.
Oh.
Why? You must have seen na wide wooden
Sir, it's
sleepers
to
are placed
prevent.
to the,
Sir, it's to prevent expansion and contraction of the train, right? Track, right?
No, that
not
no, that's different.
So that's the
why they
reason,
build,
sir.
like, no,
no, see here. Everybody see here. What
What
is the size of
Increases the
this?
area of the track.
Please see
It
here. Please
increases
see
the area
here.
of the track
What is
by
this?
supplying less
What is the size of these rails? These are nearly few centimeters, na?
Yes, sir.
Over which the wheels are there. Over which the wheels are there. Barely 1 or 2 centimeters,
Yes, sir.
right?
Yes, sir.
So how many force do you provide? What is the weight of the train? Weight of the train is tons.
Yes, sir.
Tons, and divided by, let us say that 10 to the power minus 4 meters square, because it is centimeter, I'm converting it. So it is 10 to the power 3 already, because ton is there, and in plus into 10 to the power 4. So 10 to the power 7 newtons, so much force, it will collapse inside. So that's why what we do, we provide these slippers so that
Oh, that
these
is
force
wooden
get
slippers,
distributed
sir.
in this large area. Understood?
Oh,
Those are
okay.
wooden
repeat?
slippers,
Can you
sir. I
repeat?
forgot, sir.
Sir, I thought it was to prevent
Sir,
the
that is
train track to like expand and contract due to heat.
They leave some
They did
space
it. That
in
is,
the train,
they
the
leave
track,
some
yeah.
spaces.
That is-
They leave some spaces between each rail.
Yes, yes, yes.
Yeah, when they expand, they will like come perfectly fit, and then contract will be little space. then
Everybody
the-
understood or not?
Yes, sir.
could you repeat
Yes,
again?
sir.
Just a
AC atau
Around
I'll rejoin.
if
Sir,
you
I'll
try to
rejoin
balance
because my
on
network is
Janata
lagging.
Samsat, I'm explaining the see if you like try to oh he left. Okay, see if you try to balance on a very small ledge, it will be hard move because you're applying ton of force on a very tiny ledge, right? But if there is like a plank on top of that ledge, like the more area means less pressure, right? Because they are inversely proportional. That means it will be easier for you to walk. I mean,
okay.
harder for the.
I'm explaining it again. See, Tarun, I'm explaining it again. You have tracks. You must have seen the tracks, railway tracks. So what do you see? What do you see there? You have like steel, iron rail there, right?
Bats in between.
Yeah. And then you have the nowadays we don't use that wooden planks. We use this concrete planks, right? You must have seen those concrete planks. So the rail lines that we have on which the wheel travels. So that has very less area. And when you apply a force in a very less area, what happens? The pressure increases, right? So to reduce that pressure, what we do, we provide a larger plank at the base so that the area increases on which the weight is acting.
Sir, but I have a doubt, sir.
Yeah.
Sir, why can't you just connect the rails to the ground, sir? The ground is a even bigger surface.
It'd be easier for it to derail,
No. See, you put your toe into the ground. Can you get it inside? Does your toe gets inside the ground?
What? I didn't understand.
If you put your toe, just toe, okay, try to walk on your toe. Will you collapse inside in the ground? Will that toe pierce the ground a little?
Yes,
It's not a
sir.
marble slope.
But does your feet pierce the ground when you place the whole feet on the ground? Does it pierce it down?
No, sir.
That will happen in the train also. That much less area of the tracks will sink down into the earth. Okay, so that's why we provide a larger area to reduce the pressure.
So even in people who play sports and all,
It'll
they
become
use
underground.
studs or spikes or something like that to like
Exactly.
to
have a good grip.
it'll catch the ground.
That is for
Pierce the
better
ground.
grip.
Even in
that's what I'm
ice,
saying.
when you walk on ice, you
pierce
must
the
have seen those special shoes that we use when we walk on ice. They are more
Sir,
flat.
Yes, so yes, so
Sir,
the
that is for
thing.
grip, right? Sir, that will give more grip.
Yeah, that thing will pierce
Yeah.
the ground and hold you, right?
Yeah.
Yeah.
Next thing, there is natural adaptation also that you study in biology. Adaptation you must have studied. Okay, polar bears have got
sir.
wide feet. They have got wide feet. They have got large feet, so that they can easily walk on snow.
Even
Which animal, sir? Polar bear?
Polar bear.
Polar bears.
Oh.
Wide feet so that I can easily
Sir,
walk on
so-
snow.
Sir, so you're saying if I have a wide enough foot, I can walk on water. If I have a wide enough foot.
No, that's different.
See, water is something different now. Water you have to balance. You have to be lighter than water to walk on it.
There should be air
Okay,
pockets in your body.
water we have something else. Water you can stand on water if you can displace
called
water equal to
buoyancy.
your weight. Exactly, we'll study
It's a
about it.
separate
If you
thing.
can displace the equal volume of water equal to that of your weight. For example, if your weight is 10 newton, like let us say 10 kg. Okay, 10 kg, and that this is your mass. Your weight will be 100 newton nearly, right? So
Yes,
what
sir.
you do, you have to be in such a position on the water that when you go through it, so like when you put your feet into it, water displaces, water gets displaced, right?
Yes, sir.
Isn't it? When you put your feet inside it, the water near it get displaced. So that
Yes,
displaced water is equal to the volume of your feet only. Whatever you inserted, same water gets displaced, right? But in case of
Yes,
big
sir.
ships, it doesn't happen. The dispersed part, whatever is there inside the fluid, that is equal to the volume of whole of the ship. Okay, so that's why the water displaced is
Like a
equals to
whole
weight
another
applied. Okay, yeah, that is different thing. So water displaced is equal to weight applied. If that balances, then only you can walk on it.
but it's easier
So
to
is
float
that
on your
why
back.
is that why in the bottom of the ship it is like very thin, sir?
Yes.
You go
But it's not
shark,
thin actually. It's not thin actually. It's not thin actually. It's different.
like shark.
We'll study about it later.
Sir,
I
it,
have
like,
got a
it
home.
goes very thin and after that it becomes like a bulge thing, sir.
Yeah, that bulge part, what it does, it balances the weight of water and displaced water. Weight of that thing that you're walking on, like whatever is there on the water, if that weight is equals to the displaced water, then you can float on water. That's why you can float if you are like sleeping on the water, because then your whole of the body part balances the weight of the water displaced. But if you're standing, you'll pierce it. because that displaced water is not enough.
You can never sink in water unless and until you swallow.
Yeah, you
That is also
start filling in
another
with
thing,
water
because
means
we have lungs. That is another thing, because we have lungs and lungs got air.
Natural life jacket.
Yes,
Sir,
yes.
if you diffuse a high amount of salt in water, like more than Dead Sea, is that
density,
chance?
density more ardent, more
There
than
is
ardent.
another thing that will increase the viscosity, and that's why you can float. So all these, you are taking me to different level, right? I can answer all your questions, but I need to explain it to you. You just distract me. See here, I got a homework for you. You have to find the relationship between 1 Pascal and 1 dyne per centimeter square. You can do it with dimensions. This is your homework. Okay, conversion of units we have studied now.
Yes.
This is your homework.
So we don't have a class tomorrow.
Yeah. I mean, not his class. We have classes.
Okay, now let us move on. So these reasons also you have to write. I'll see in the next class. You have to write these reasons. I've explained it.
We have 20 minutes more, sir.
What?
So hydraulics will be in this chapter, sir.
Pardon?
Hydraulics.
Hydraulics. Let us see. I've not seen the full chapter. We'll go accordingly.
Then I'll check.
Maybe that may be there. Okay, now we'll see the
Oh yeah, hydraulics.
pressure in
Yeah,
fluids.
that's not that.
Pressure in fluids.
The hydraulics is basically water pressure, right, sir? Like water
No,
is
it's
being
air
cornered
also.
to one place and
Sir,
like
can you go to the
sometimes
previous
air.
slide for a second?
Yeah, hydraulics contains very wide contents that you even don't know. Leave those
Yes,
things.
sir.
Written, Tarun?
Yes, sir. I was drawing the diagram. Yes, sir.
Okay. Done.
Sir, but they usually use liquids in hydraulics than gases also because liquids can gases can compress. Hey, wait,
Hey,
because
sir just said it's
gases
a
can
wide
compress.
topic and we'll be learning in this chapter, so have patience.
Sir, I finished.
Exactly. You have to be concentrated to the chapter itself. You are going. Hydraulics, like something, motion of a liquid under pressure. We'll be studying fluid statics, and let me see if we have hydraulics. All those are different things. Please don't take me to that. See, pressure in fluid, because I don't want to explain it to you according to your level. Nah. There are many things that you study now and that they'll be discontinued further. They'll be saying, no, you have studied it incorrect. It was just to explain it to you. So there are many things. Okay,
So we
because
do
I
have
cannot explain
hydraulics
everything. There are levels.
in our chapter.
Okay, so pressure in fluids. What happens? A
Yes,
fluid. What is fluid?
So anything that
So a
can flow.
gas or a liquid, yeah, anything that can flow.
Not a good definition. Next thing. Next, anyone else? What is fluid?
What else can I see?
Sir, it's anything that can flow, sir. Flow free.
This is the best
That's
definition.
what I said, bro.
Anything that flows.
So that's what they said.
Okay.
We
Exert
didn't hear.
pressure at all points. So it's the same thing but different way.
Okay. Oh, Nitish, you also said the same answer.
Yeah, what do you
Even I
think I
said the
said, sir?
Sir, all four of us said the same thing, sir.
Okay.
Yeah.
Hey,
No,
you didn't
you
say.
you certainly said the examples. You cannot write it like this.
You said liquid and water. I mean, liquid and gas.
If you have to, you must have been studying chemistry. Huh?
I said it
You must have
after that.
studied matters and surroundings like chapter.
Yes, sir.
How do you
Yes,
define
sir.
matter?
Seventh.
This pen is a matter.
The matter is anything that can occupy space, can be perceived by senses, and then
It's mass.
Matter is a chapter that we have both in physics and chemistry.
Anything that
throughout
occupies
our-
space and has got mass is called matter. So how do you say that? This pen is a matter, sir.
Sir, matter
Yes.
matter actually occupies a lot of space in our chemistry and physics textbooks, sir.
You have to define it. Now you don't have to give examples. Written.
What
Okay. So what is pressure in fluids? If you keep a bottle, okay, you must have seen this. If you keep a bottle
will bulge?
and put water in it, so what will happen? You can see that at the bottom,
Lower
if you put a hole in the bottom, if you put a hole somewhere here, if you put a hole somewhere here, if you put a hole somewhere here, and if you put a hole somewhere here, okay, so what will happen? From all these holes, you'll see water coming out.
The lowest
Water
hole
coming.
will have more force.
Yes.
more pressure.
From all these holes, you'll see water coming
will
out.
go further. Water will like slide out further than most of the others.
Okay, and one more thing, the pressure, because they are under pressure, that's why they are coming out. For example, you feel yourself. This is a classroom. Okay, this is a classroom, and there are people here. Okay, everywhere, people here. This is the condition of the class, and in one classroom, the condition is like this.
Oh no.
They are
Maybe
forced into the
yeah.
classroom. Okay, they are forced inside it. There are more number of students that could have been arranged in it, and this is the door. Now the door is closed in both of both of these cases. If I open the door, will the students get thrown out of this class?
No, sir.
What?
Yes, sir.
No,
Students
they'll
get
go
thrown out
No, sir. No, sir. No, sir. No, sir.
in this class.
Yes, sir.
queue.
In class 2,
Yes,
Yes,
sir.
sir.
they'll be thrown out. Why? Because they are kept under pressure, isn't
They
it?
will suffocate. They'll nearly.
No, what I'm
They
saying,
would
what
like
I'm
that.
saying that when you open the door, the students will get thrown out of towards yourself, isn't it?
Yes, sir.
Same thing happens here in this. They are forced here. What happens now when you keep the water like this? The atmosphere provides the force. Okay, see here what happens. Let us say this is the sea level. This is the sea level. These are mountains. Until here we have sky, the mesosphere, right? And this is of the order 10-20 kilometers like that above the earth's surface. Okay, 10,000 kilometers like that, it goes above the earth's surface to get the space. Understood? So what happens here? Air particles, you are standing here at the sea level, so air particles are there above you, isn't it?
Yes, sir.
Nothing is there, that means air particles are there above you. Everyone agree or not?
Yes, sir.
So
Sir.
air particles also had got mass. They also has got mass.
Yes, sir.
Yes, sir.
Yes, sir.
Understood, everyone? So
Atmospheric
if he has
pressure.
got
Yes,
mass,
sir.
if he has got mass, they must be getting weight. If I take just the position above your head, can I get something like, yeah, this? I'm taking just the position above your head like this. Okay, from your head to the mesosphere, and this is space. From your head to the mesosphere. Okay,
Yes, sir.
and this is, let us say, at height h. So in this space, there must be air particles.
Sir.
The density of air particles is around 1.26 kg per meter cube. That means in 1 meter cube, if you take 1 meter cube, 1 meter length, 1 meter breadth, 1 meter height of a cylinder, and you place air in it, so what will be the weight of that thing? That will be 1 kg, 1.26 kg around.
Yes,
Understood?
that's so much.
So you see, if you go for 10,000 kilometers upwards, 10,000 kilometers upwards.
Sir,
So
you go to
how
outer
much?
space, sir.
How much? No, the 10,000 kilometers is the level of this atmosphere.
What?
Okay.
No, no.
Sir, I thought it was only 4,800 kilometers, sir.
Let me
It's
give
not
you
even
that.
that many kilometers, sir. Sir, it's like 1 hour drive from here to outer space, sir, in a car.
You saw that in YouTube shorts, right there.
No, I like actually it's written in a book also. It's written in every single
See,
book.
10,000 kilometers. First, listen now. 10,000 kilometer upwards is what? Space. Okay. How many layers of atmosphere do we have?
Space.
42,000, sir.
How many layers of atmosphere do we have?
5.
So 7.
Right.
No. No.
You failed geography also.
See, sir. Troposphere, stratosphere, ionosphere, mesosphere and ionosphere same. And then there's 5, sir.
Basically, we
Exosphere,
have 7: troposphere, stratosphere, mesosphere, thermosphere, then exosphere, and then
That's it,
magnetosphere.
sir.
So we can say 6,
Okay,
but I know 7. Okay, see here.
Sir,
Since
Uh,
when did we have a magnosphere?
That is there. You have not studied. That's why I said no. You have not studied many things that you need to study in the future. Now see here.
Sir, it's only
Here.
100 kilometers.
Yeah, they are under 100 kilometers. That was a mistake. That is 10,000 meters, not kilometers. Now see here. So from 10 kilometers or 10,000 meters, not 10,000 kilometers. My mistake that was. So 10,000 meters, you get to start of the end of the atmosphere. Okay, and then it ranges between 50 to 60 kilometers, and then it ends. After that, you get to this outer space. Understood? So till let us say 20 or 30 kilometers, we have the air. Above that, you cannot breathe. Okay, above that, you get less of that. So understand here, it's very serious here. See here. So let us say that in 1 meter you have around 1.26 kgs. So you're getting above to 50 kilometers. In 50 kilometers, how many meters are there? 50 kilometers means what? 50,000 meters.
Yes, sir.
So 50,000 meters. Okay, and then I'm taking this was the length, this was the breadth, and this.
Book.
If I'm taking a cube,
0.2.
Oh, yeah, it's correct.
sorry,
only.
cuboid. See here, I'm taking a cuboid here. I'm taking a cuboid here of length 50,000 meters.
Yes, sir.
This breadth 1 meter and this 1 meter. Okay, so what will the volume? Volume will be 50,000,
Yes, sir.
Yes, sir.
and that you multiplied with the density. How much mass you'll get? You multiply with g, and that is being acted upon how much area? That is 1 meter square, because base is 1 in 1, right?
yes, sir.
Yes, sir.
You can imagine how much force you get above it, and that is atmospheric pressure.
So, but we don't feel it.
We won't feel it.
We feel it, but it's
Well,
very minute.
Sir, but it is a lot more in the oceans, right, sir?
So because
No,
it's water
the thing is that see, it is not lot in the ocean. The thing is that ocean is the basest point, the most base point of the earth. Okay, that on which you can stand. Understood? So the height increases. When you go to the mountain, the height decreases. Are you getting my point?
What?
Or the deepest
Yeah.
point, the height.
If you stand
Oh
here,
yeah.
if you
Oh
stand
yeah.
here,
Okay.
the height above it will decrease now.
Yes,
So that's
sir,
why
yes, sir.
you feel less pressure, you feel breathlessness, those things happen because we are acclimatized, we are
So
adopted to
when
live on
you
land.
go to the bottom, when you go to the bottom of the ocean, it adds up to that. It adds the atmospheric pressure and the water pressure, and then puts it on
Exactly.
us.
So that's why you must have heard the recent case of that Titan ship.
Yes, sir. Yes, sir.
Hear that? So what happened?
Sir,
That ship broke, and all the people would have died at once because they would have felt 10 or 20 weights of elephant there on their head suddenly.
yeah, just about to say that. Just about
Those submarines are designed in such a way that you don't feel the pressure. But if those broke out, you'll feel the weight of around 20 to 30 elephants above you.
Yeah, you won't feel anything, sir. You'll die before you feel anything, sir.
Exactly.
You know
They
that.
put
Understood?
You know that.
So
Understood?
that we have
So
seen
same pressure acts on. See here, same pressure acts on this. Same pressure acts on this water surface, and they pushes it out. Okay. So what happens at a same level of height? The pressure is same. Okay. If you go to the same height, the pressure is same. But at different height, the pressure is same. P2. Understood or not? It is all the matter of height. Understood?
Yes, sir.
Yes, sir. So then, what about in outer space, sir? There is like
Outer
no,
space,
nothing
those air particles are not present. Those air particles are not present.
there are, sir. So there
There
is
is
no
no
pressure at
pressure
all.
there. There is no
Exactly.
pressure at all. You can
Okay.
make
So
graph.
did you find this interesting? Did you find this interesting?
Very.
Yes,
So look
sir.
like that man is shooting a Kamehameha on the sky, sir.
To make it more interesting, let us calculate. We just read na. We just read here na that 1 atmospheric pressure is how much? 1.013 10 to the power 5 Pascal, right? Let us calculate it. Let us calculate it. So pressure is what? Force upon area. So let us take. We'll calculate it averagely because we don't know the exact height of the atmosphere. Okay, so we'll calculate it averagely. We'll try to reach to this point. So now see here what we're doing. We will be taking the density of air to be 1.24 kg per meter cube, right? This is the density of air. Now we'll take a column of 1 meter length, 1 meter breadth, and 50,000 meter height. Because we'll assume we don't know exactly what is the exact height of atmosphere, but we'll assume it to be 50 kilometers. Okay.
100, sir.
So,
We'll ask
huh?
It's actually
Actually, it ranges from 50 to
100
20.
it's exactly it's exactly 420 kilometers, sir.
Exactly, that's what I said. It ranges between a certain limit, but what happens now? You get the air in the initial phase only. Till the last extent, you don't get the air particles. Okay,
Yes.
so we'll assume
yes,
it to be 50. Let us calculate this. So can you tell me what will be the mass? First you tell me what is the volume of this? Volume?
volume of
Uh,
so it'll be 50,000, sir.
50,000
50,000
meters
meters
square.
So density is what? Mass upon volume?
Yes, sir.
Mass by volume.
Density is mass upon volume. So what is then mass?
Yes.
Mass is density into
Mass
volume.
is 1.2. Oh, that's density. Sorry. Mass is
So density is what?
so
1.24 and volume is 50,000. So tell me this, what is mass?
Let me calculate.
Your understanding?
1.24 into 50.
Sir, it is 62,000. 62,000,
Yes,
sir.
62,000.
62,000.
Yes, sir.
Yes.
That much kg is the mass. So what is the weight? So
The
62,000
weight is equal to 62,000 into
10. I'm taking
9.8.
I'm taking 10. I'm taking 10 to easy calculation. I'm taking it to be 10.
Sir, 620,000, sir. 620,000.
No.
To ease the calculation, I'm taking it to be 10. Now see here. So now see here. So this weight is the force that we are applying, isn't it?
Yes, sir. Sir,
If
it's
you want to calculate
620,000, sir.
620,000
620,000.
upon area 1 meter
You
square.
missed a zero, sir. You missed an area. Zero, sir. You missed a zero.
So it's 620,000, sir.
Understood?
So
Upon 1 meter square.
620,000 Newton meter square or Pascal.
This is how it goes. See here, how much it is. So can I write this thing as 6.2 into 10 raised to the power 5 newtons?
Yes, sir. Yeah?
Yes,
Yeah,
sir.
yes, sir.
Yes, sir.
But what we got as the pressure 1.013 into 10 raised to the power 5, na?
Yes, sir.
Yes, sir.
That means
Sir.
the density of air is not uniform to the 50 kilometers. It is decreasing with height. That's what I was
Sir,
saying. Understood?
Okay.
The density
Yes,
goes
sir.
on
Sir,
decreasing
it
with
is
height.
Sir, is it because in the first sir, is it because in the first troposphere and all it is and it is like very heavy gases, but as it goes very high, we find
Height gases we
very
get
light
as in the
gases.
above atmosphere. Understood, everyone?
Average, right, sir? You can take the average.
Yes, sir.
Understood or not, everyone?
Can you hear me?
Yes, sir.
So we
Yes,
can
sir.
calculate.
Yes, sir. We can
We
hear
can
you.
assume this density. We can assume this density till 10 kilometers only. That's what I was saying. 10,000 meters. If you will calculate by assuming it to be 10 or 11 kilometers, now you'll get the exact answer.
Sir,
Understood?
but we can take the average of all the weights and then we can find out.
No, we cannot do it like that. We'll have to then examine a very large part of the atmosphere. Kongwe, are you not there?
Yes, sir.
Are you not there?
Well, is gas. I don't know.
Hello?
Yeah, you're there.
Hello.
So understood, everyone?
Yes, sir.
Okay. Next, the last topic for today, we'll try to calculate the area, the pressure at a certain height. Let us say
So,
we have this
Sanka
bottle.
opens. Face is getting
This is
brighter.
we have to calculate the pressure at this height h. Okay, and what else can we do?
Volume.
Okay, let us say that density is rho. Density of this liquid is rho. Okay, this is height h. The base area is a. Okay, now we have to calculate at a height h. Okay, now see here. What is pressure? Pressure is force upon area. Force is what? Force is due to the self weight at this particular point. Please listen here carefully for here. Don't write anything. The force at this particular point is what? Due to the self weight of this much amount of water,
Yes, sir.
isn't it? So how much this much amount of water will be? First, we need to calculate the volume. What is the volume of this particular area? So volume will be what?
H.
Area into height.
Yes, sir. Area.
Volume is area into height. Everyone? Any doubt?
Yes, sir. No, sir.
Sankalp,
No,
any
sir.
doubt?
No.
Kongwe,
No,
Tarun?
sir.
No, sir.
Okay.
Well, sir.
So area into height is volume. So what will be the mass? So from here we know that density is mass upon volume.
So mass is equal to density into volume.
Will be equals to density into volume. Density is rho, volume is area into h, right?
Yes, sir.
So what will be the weight? Force is equals to weight. Weight is what? mg. So rho, a, h, and g. So pressure will be what? Force upon area. So rho, a, h, and g divided by a. So that will be rho g h. Understood? So for a liquid, so for a liquid, if density is constant throughout, pressure is directly proportional to height because g is not going to change, isn't it? Understood, everyone?
Sir. Yes, sir. Yes, sir.
So that's all for today. We'll solve questions on this, but I won't ask you to get it prepared. You'll first prepare for the exam on 30th, and then we'll move on. Okay.
Yes, sir.
Thank you,
Okay.
sir. Bye, sir.
That's it. Written,
Thank you, sir.
everyone?
Bye, sir.
Yes, sir. I
Yes, sir.
finished, sir.
Sir, it's actually been 10 minutes since the previous class started.
Okay. So can we end it
2
now?
minutes, sir.
Yes, sir. Thank you, sir. Bye,
Tarun,
sir.
Thank you,
written?
sir. Bye, sir.
Can you go to the previous slide?
Yeah.
Sir. Yeah. Yes.
Written.
I'll just mention. Okay, 1 second. Sir. Thank you, sir. Bye, sir.